I thought this was an interesting problem. Find all the radian solutions. All right, so we have tangent of x times sine squared of x equals tangent of x. All right, so if I'm going to solve this, I'm going to get, I see I have tangent in common. So the first thing that makes sense to me is to get everything over to the same side. So when I do that, I have tangent of x sine squared of x minus a tangent of x is equal to 0. Now I'm thinking like quadratics. I'm thinking like factoring. What can I like extract out of here? And I see I can factor out a tangent x, right? They both share. Both these terms separated by subtraction share a tangent of x. So I'm going to factor out the tangent of x. That's going to leave me with a sine squared of x minus 1 is equal to 0. Now I have a product equal to 0, so I can apply the 0 product property. So tangent of x is equal to 0, or sine squared of x. So we could say sine squared of x minus 1 is equal to 0. So now I can just use my inverse operations here to add 1, take the square root. So hopefully you see that sine of x equals plus or minus 1, right? Add 1, then take the square root of both sides. But just like it did in the previous problem, when you do take the square root, you got to include plus or minus. And then, so it's tangent of x equals 0, or sine of x equals plus or minus 1. Again, that or is very important, right? So now let's go and take a look at, because it could be one or the other or both. Because now let's go and look at the unit circle when these values are going to be true. So remember, tangent of an angle represents the y coordinate over the x coordinate, right? Tangent of an angle represents the y coordinate over the x coordinate. So we want to know when y over x is going to equal 0. It's kind of interesting, but let's look at some points here. What about this point? Oops, ran out of space. I knew it. That's why I kept on looking over here. I'm like, I'm going to run out of space eventually. Let me see. There we go. Haha, perfect. Okay. I use my blue. So tangent theta equals a y over x. So that's going to be 1 comma 0. So if I was to do that, it'd have y, which is the 0 over 1. So you can see how this one works. And then over here, this would work as well, because this is negative 1 comma 0, right? So therefore, we have two solutions in this case. We could have x is going to equal, now you could say 0, pi, 2 pi, 3 pi, right? So the way to summarize that would be pi plus a pi n, where again, n represents any integer, positive or negative. And then over here, it's saying when sine is equal to plus or minus a positive 1. Well, that's going to be up here or over here, right? Because if you look at this point is 0 comma 1, sine is positive 1. And over this point, sine is equal to negative 1. Because remember, sine of theta equals your y coordinate. So for these solutions, I have x is equal to a pi halves plus a pi n. Because again, if here's your one solution, if you add pi to it, it goes here, add pi again, add pi. Or since n is an integer, you could subtract n, and n could be negative. But in reality, ladies and gentlemen, what we can see is all of these are just a quarter of pi away from each other. So my final solution is because the question was find all the radian solutions. That is just going to be x is going to equal a pi halves. That's kind of like my first solution. Well, actually, yeah, it doesn't really. Pi halves n, actually. Yeah, pi halves n. Because if n was 0, I would have 0, which is a solution, and then go from there. So that would be my final written solution.